Greetings everyone, this is Mr. Mull, and really quickly in this video I'm going to go over the rules needed to count significant figures. When I say significant figure, all we're talking about is values that we actually measured in the lab. If you measured a value, it's significant, and so there's rules for counting the number of significant figures in different measured quantities. So, sig fig rule number 1, that non-zero numbers are always significant. So for example, if I have a number like 1, 2, 3, 4, 5.6, I look at all these numbers and every single one of them is non-zero, it's not zero. So all of these non-zero numbers are significant. So I count them. There's 1, 2, 3, 4, 5, 6 total non-zero numbers. That means this number has 6 significant figures. The only way we get a number like 1, 2, 3, 4, 5.6 is if we actually measured all those numbers. So this is the first sig fig rule. The second sig fig rule deals with zeros. And so there's 3 types of zeros. The first type are called captive zeros. So a captive zero is a zero that's kind of like trapped or captive between 2 other numbers. So for example, if I have like 1009, those zeros are captive between those other 2 numbers. So whenever we have captive zeros, these are always significant. Those are going to always be significant. So we're going to go ahead and count all those numbers, the captive zeros included. There's 4 sig figs there. The next type of zeros that you could see is what's called a leading zero. So let's say I take out a meter stick and I measure it to be 9.1 millimeters. Now, 9.1 millimeters, in terms of millimeters, these are both non-zero numbers, 2 significant figures. However, when I convert this to meters, so let's say I divide this by 1,000 and I get 0.0091 meters, you'll notice that I only measured the 9.1. But when I look at this number here, 0.0091 meters, it looks like I have all these zeros now. Well, those zeros are just placeholders to what I actually measured. So those leading zeros are not significant. I didn't measure them. They're just placeholders. So any leading zeros are never significant. The last one we have is called trailing zeros. And so trailing zeros might be something that looks like this. So I go and make a measurement. Let's say I had, 9.1 times 10 to the 5th. So let's say I have some instrument, it measures 9.1 times 10 to the 5th. Let's say that's meters per second, something moving really, really fast, close to the speed of light. If I were to convert that and expand it out into regular form, 910,000, those zeros are just going to be placeholders as well. We only measured that 9.1. So trailing zeros, if there's no decimal, then those trailing zeros are not significant. Okay, they're not significant. However, if I were to measure using a really precise instrument that I have 910.000, let's say I change the number. Well, now if I have a decimal, that means that someone has measured that to be, not only is it close to 910, but it's really close to 910 on the dot, on the dot, on the dot. Those 3 zeros are measured. So each time I add a 0, you're saying it's more and more and more precise. And so trailing zeros with a decimal are always significant. Those are measured. Okay, someone actually measured that it was on the dot, on the dot, on the dot. Okay, I like to sum up these rules into just 2. So if you can memorize these, you'll know all the rules for counting sig figs. Takes all these and puts them into 2 rules to rule them all. The first rule is called the decimal rule. So if there's a decimal present, in order to count sig figs, I'm going to put a little circle by this decimal, this D. If there's a decimal present, all you have to do to count sig figs is you're going to count from the first non-zero to the end. End. Decimal rule, go to the end. Okay, think that D sound. Decimals present, count the first non-zero to the end. So if I have a number like this, I look and I notice there's a little decimal hanging out. So I'm going to count from the first non-zero, which is 9, all the way to the end of the number that's written. And I'm going to count all those numbers. 1, 2, 3, 4, 5 sig figs. Decimals present, count from the first non-zero to the end, including zeros if there's a decimal. But remember, you have to start from the first non-zero number. So if I were to do this one here, there's a decimal present, so I find the first number. It's 9, the first non-zero number to the end. 3 sig figs. Okay. Second rule. The second rule is just the number sandwich rule. Number sandwich rule says this: if there's no decimal, then you make a number sandwich. Okay. I want you to think of that N. No decimal, number sandwich. When do I make a number sandwich? When there's no decimal. So if I have a number like this, I notice that there's no decimal in the number, so to count the number of sig figs, the ones that actually were measured, we're going to make a number sandwich, including each non-zero number. So I take the first number and the last number that's not zero, and I make a little sandwich. And count, you can count the buns and the number in between. So 1, 2, 3, we have 3 sig figs. All those rules can be summed up into 2 rules. If there's a decimal present, start counting at the first non-zero to the end. If there's no decimal present, then you're going to make a number sandwich. This was a quick recap of how to count significant figures, and I hope that this was helpful.